Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video we learned the last question of exercise number 9.1 related with chapter number 9 differential equation relevant with the topic initial value problems. So in today's video I am going to start a new exercise number 9.2, which is the last exercise of chapter number 9 differential equation related with FSC Part 2 mathematics. In today's video I will solve the very first question of exercise number 9.2 related with the general solution of the differential equation. So let's move toward lecture number 6 or differential equation chapter number 9 FSC Part 2 mathematics exercise number 9.2 question number 1. Find the general solution of the following differential equation. We already learned that what is general solution in the previous exercise number 9.1. So if we have a differential equation in term of two variable and dependent variable and it is dependent upon a single arbitrary constant c, so the solution obtained is called the general solution of the differential equation. So let's move toward part number 8. 2x dy over dx minus 2y divided by x square is equal to 0. So we are going to generate the general solution for this differential equation. So shift x square on the right hand side, so it becomes 2x dy over dx minus 2y is equal to 0 multiply x square, it will give us 0. Now shift minus 2y on the right hand side, so it become 2x dy over dx is equal to, it become 2y. So 2 cancel out with 2, we left with dy over dx is equal to y and divided by x. Now using separable differential equation, shift y values on one side and x value on another side. So shift dx on this side, it become dx, and a division we have x. And shift this y on the left hand side become dy over y. Dy over y is equal to. So now taking integral on the both sides, so 1 over y integration is ln of y is equal to integration of 1 over x is ln x. And with constant we can take ln because c is a constant, and by taking ln is also a constant, it will give us still a constant value. So after this ln of y will be, over here ln of a plus ln of b formula will be used, ln of a plus ln of b. This is equal to ln of ab. It means these two terms will multiply with each other, it become ln of cx. Now taking exponential on the both sides, so e and ln cancel out on both sides, so we left with y is equal to cx. So this is the required general solution, because in this solution this dependent variable y and independent variable is dependent upon a single arbitrary constant. That's why this is the general solution of the first order differential equation. This is first order differential equation because the highest power of the dependent variable y is 1. So this is the required general solution. Now let's understand the next part number b of the same question number 1. dy over x plus y dx is equal to 2dx. Let's move toward the solution of this part number b. So taking dy divided by x as it is, shift y dx on the right hand side, so this 2 dx will come down as it is, this is plus y dx, so by shifting to the right hand side it becomes negative y dx. So by further simplification, dy over x will come down as it is. From over here dx is common, so take it outside. So over here I left with 2, and over here by taking dx common we left with negative y. Using separable differential equation, shift 2 minus y on the left hand side, it become dy over 2 minus y is equal to, shift x on the right hand side, it become x dx, and take a indefinite integral on the both side. So 1 over 2 minus y integration is just ln of 2 minus y, because the general integral 1 over x dx is always equal to ln x. So same wise comparing with this form, 1 over 2 minus y integral will be ln of 2 minus y. Now but remember one thing, in differentiation of 2 minus y will be, 2 differentiation is 0 because this is a constant, and minus y differentiation with respect to y is negative 1. So over here I will write extra negative sign. Integral of x is x square divided by 2, and use plus constant of integration. After this, shift minus on the right hand side, so ln of 2 minus y will be, multiply minus with x square over 2 will become minus x square over 2, and minus multiply constant will give me still a constant c. After this, I remove this ln, so I will take exponential on the both side. So exponential power minus x square over 2 and plus constant c. So exponential and natural logarithm cancel out with each other, we left with 2 minus y is equal to, over here I will use this formula, a power m plus n will be equal to a power m into a power n. I just split these two power and the base will same. So the base will be e in the both cases, and the power will be according to this formula. We will write separate the power minus x square over 2 and separate power c over here. So e is exponential is a constant, and this c is also constant. So constant to the power constant gives me still a constant c. So I will write c over here. E power minus x square over 2 into c is equal to 2 minus y. Shift minus y on the right hand side it become positive y, and shift this value on the left hand side it become negative. So 2 minus e power negative x square over 2 into c. So the required solution is y is equal to 2 minus e power negative x square over 2 into constant c. This is the required general solution. Now let's understand the next part of part number c. dy over dx whole square is equal to 1 minus y square. Move to solution. Taking the given differential equation dy over dx whole square is equal to 1 minus y square. First I remove this 2. So how can I remove? I will take just the square root on the both sides. So dy by dx whole square, taking whole under the root is equal to, also take under the root on the right hand side, it become plus minus 1 minus y square under the root. So square and under root cancel out with each other. We left with dy over dx is equal to plus minus under root of 1 minus y square. Shift plus minus y square under root on this side using separable differential equation. So it become dy plus minus, it will move to the denominator over here on the left hand side, because over here it is in multiplication. So plus minus 1 minus y square whole under the root, and shift out dx on the right hand side and taking the integral on the both side. Remember that the integral of 1 over under root of 1 minus x square is always equal to sine inverse x. So over here variable y is used instead of x. It means the required answer of integral of 1 over square root of 1 minus y square will be sine inverse y. Just replace x with y. So their answer will be plus minus sine inverse of y is equal to integral of dx is just x and plus constant of integration. Shift out this value on the right hand side, so we just left with y. So y will be equal to plus minus, over here it is sine inverse, so by shifting to right hand side it becomes sine time of x plus c. This is the required general solution. Now let's understand the next part of part number d. E power x into dy over dx plus y square is equal to 0. So move to the solution. Writing this term as it is e power x dy over dx. Shift y square on the right hand side it become negative y square. Now over here shift y square on this side and dx and e power x shift on the right hand side. So over here y square is in multiplication. So by shifting to the left hand side it will move to the denominator and move to the division. So dy over y square. After this dx is in division, so by shifting to the right hand side it will move to the multiplication dx. E power x is in multiplication, so by shifting to the right hand side it will move to the denominator. So 1 over e power x, and write this minus as it is and taking the integral on the both side. So over here shift y, it will move to the numerator, it become y power negative 2 into dy. So over here it is equal to minus time of shift e power x to the numerator, it become negative e power negative x and dx. Now taking the generalized power rule, using generalized power rule, so add 1 in the power, so minus 2 plus 1 and write the same power minus 2 plus 1 in the denominator. Over here minus time of integral of e power x is e power negative x, and the differentiation of the inner function in the denominator will be minus x differentiation is minus 1 and plus constant of integration. By further simplification it become y power negative 1 divided by minus 2 plus 1 is minus 1 is equal to minus into minus will give us plus, so it become e power negative x plus c. After this it become minus 1 will move to the numerator and y power negative 1 will move to the denominator, become positive power and e power negative x and plus c. Now reciprocating both sides, so it become minus 1 over y is equal to 1 over e power negative x plus constant. So it will be minus y is equal to 1 over e power negative x and plus c. So the required y will be minus 1 over e power negative x plus constant c. This is the required general solution. Now let's understand the fifth part of part number E of the same question number 1. Square root of 1 minus x square into dy is equal to square root of 1 minus y square into dx. So let's understand this question step by step. So taking the given differential equation square root of 1 minus x square dy is equal to square root of 1 minus y square into dxo. So divide both sides with under root of 1 minus x square. So over here these are cancelled out with each other. We left with dy is equal to under root of 1 minus y square divided by under root of 1 minus x square into dxo. Now over here we have dy and over here we have square root of 1 minus y square. So we will remove this from the right hand side. So I will divide with square root of 1 minus square both sides. So divide both sides with under root of 1 minus y square. So on this side we left with under root of 1 minus y square divide with under root of 1 minus y square. This will come down as it is under root of 1 minus x square and this dx will come down as it is. So these are cancelled out with each other. So we left with dy divided by square root of 1 minus y square is equal to dxo divided by square root of 1 minus x square, and taking the integral on the both sides. So this is actually the formula that 1 over under root of 1 minus y square is actually equal to sine inverse of y. Because if you differentiate sine inverse y, it will give us under root of 1 over under root of 1 minus y square. Same for the right hand side, 1 over under root of 1 minus x square integration is sine inverse of xo and plus constant of integration. Now shift sine inverse on the right hand side. So over here we left with y, and by shifting sine inverse on the right hand side it becomes sine. So sine into sine inverse xo and plus constant of integration. So this is actually the required general solution. Now let's understand the last part of today's lecture, part number 8 of the same question number 1. Cosecant square x dy plus secant y dx is equal to 0. Move to solution. Cosecant square x dy will come down as it is. Shift secant y dx on the right hand side, it become negative secant y into dxo. So shift this cosecant square x on the right hand side. So how? I will divide both sides with cosecant square xo. So on this side I left with dy, and on this side I left with minus secant y into 1 over cosecant square x is actually sine square x because these are the reciprocal, and I left with dxo. Shift secant y on the right hand side, so I will divide both sides with secant y. So on this side they are cancelled with each other. Over here 1 over secant y is actually cos of y because secant and cos are the reciprocal. So over here I left with negative sine square xo into dxo, taking integral on the both sides. Over here the integral of cos y is sine y, but over here there is no formula to find the sine square x integral directly. So over here remember that cos of 2xo, by using the half angle identity, it is equal to 1 minus 2 sine square xo. Now shift 1 on this side, it becomes cos of 2xo minus 1 is equal to minus 2 sine square xo. So shift minus on this side, it becomes 1 minus cos of 2x is equal to 2 sine square xo. Further sine square xo will be equal to divide with 2, so 1 minus cos of 2x divided by 2. So put sine square x over here. So it becomes minus integral of sine square x is 1 minus cos of 2x over 2 into dxo. So further sine y will be equal to minus time of it can be written in a split form 1 over 2 into dxo and minus cos of 2x over 2 minus cos of 2xo over 2 into dxo. So sine y will be 1 over 2 is a constant, so inside we left with 1 dx. 1 dx is actually minus xo. Integration is minus xo minus x over 2 minus minus plus o. Over here we have 1 over 2. Integration of cos of 2x is sine 2xo. But over here this is inner function, so we will differentiate it in the denominator and plus constant. So sine of y will be equal to minus x divided by 2 plus it will go the sine 2xo divided by 4 plus constant of integration. So the required value of y will be shift sign on the right hand side, it becomes sine inverse of minus x over 2 plus sine 2x over 4 and plus constant of integration. This is the required general solution. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.